All right, we're going to find the intervals for where this function is increasing and decreasing. So step one is we're going to find the derivative function. So we'll bring down the 3, subtract the power, bring down the 2, subtract the power, bring down the 1, and then that becomes x to the 0. So our derivative function will be a quadratic function. Step 2 is to set the derivative function equal to 0 and solve for x. So in a previous example, we factored the function and then used our zero product property. Instead, we're going to use technology to find those critical points. So on another video, I'll show you how to type this into a graphing calculator to find those x values. So here's what it'll look like when we type it in, and then these are your, what we call the zeros of the function, or in a sign diagram, your critical points. So again, in another video, we'll show you how to do that. All right, so now that we have those critical points, we can set up our sign diagram. So on our number line, here's -1/2, and then here's 2/3. These are your critical points. And then what you would do is you would test something like x equals -1 into the derivative function. And what you get out is a positive slope. So this interval right here would be positive. Then you would test something between -1/2 and 2/3, so 0. And you would substitute 0 into the derivative function and you get a negative. So that interval is going to be decreasing. Then you'd substitute 1 into the derivative function. And when you're done, you're going to get a positive slope. So now we're ready to identify the increasing and decreasing intervals. So it's increasing in this interval. So how we write that is x is greater than or equal to 2/3. And then this interval, where it's increasing, is going to be x less than or equal to -1/2. All right, and then this interval is decreasing because its slope is a negative. So we put the x in the middle. We say x is greater than or equal to -1/2 and less than or equal to 2/3.